Alright, so problem number 79, chapter 3, has two clowns, clown A, clown B. It gives you their separation, 6 meters, and it tells you that A is launched at 9 meters per second at 75 degrees. So, we can first break clown A up into its y and x velocities, using sine and cosine. And then we can say, based off of this, how high would clown A be after 1 second, because it says they collide, or after 1 meter. It says they collide 1 meter above the cannons. So I plug in its y initial velocity. I plug in gravity, 10, and I plug in 1 for 1 meter up. How long does it take something launched at 8.7 meters per second under the influence of gravity to get 1 meter? And I get a time quadratic here. If I use the quadratic equation, I get 2 possible answers. So it's going to go 1 meter in 0.123 seconds immediately, and then it's going to also, on the way back down, hit 1.6 seconds. So I'm going to choose that one. I'm assuming that it's on its return trip down at the second time it crosses 1 meter, which is 1.6 seconds. Alright, so from there, I can find out the distance that it collides, because if I know it's 1.6 seconds and I know its x velocity is 2.3 meters per second, it would have hit 3.2 meters over from cannon A. So if I do subtraction of 6, I can find that it's 2.3 meters from cannon B. Therefore, I know that clown B's x velocity, which is constant, covers 2.3 meters in 1.6 seconds. That makes it 1.45 meters per second. If I can just find its y velocity, I can use Pythagorean to get the overall velocity. So I'm going to plug in the y direction now, 1 meter. I'm going to plug in the time. I know they collide in 1.6 seconds. And I'm going to plug in gravity. And I'm going to solve it now for initial y velocity. They must have collided at the same instant, 1.6 seconds. So that gives me a clown B y velocity of 8.625. Now I know its x and its y velocity, so I can do a squared plus b squared equals c squared. From there I can do inverse tan and get an answer 8.7 meters per second at 80 degrees for clown B's launch.